Welcome everyone to our webinar today titled Crumb Rubber, brought to you by Ecologiq and ARRB. My name is Isabella and I'll be moderating the session today. Next slide, please. We have planned to go for 60 minutes with time for questions at the end, and we'd love to have your input throughout the presentation. So you see here on the slide how to send your questions through. Now we are following the government guidelines and all coming from our home offices, so fingers crossed all of our technology works. However, we also have Neva and Susie from ARRB joining in for technology support. Next slide, please. Our presenters today are Tony Alosio, Director, Ecologiq, Joe Grobler, Principal Professional Leader, ARRB, Steve Patrick, Senior Technology Leader, ARRB. Next slide, please. All right, let's get started, and we'll now be hearing from Tony.
Thanks very much. I'd like to start by giving an overview of Ecologiq and the Recycled First policy. And move on. So Ecologiq is a Victorian government initiative, and it will optimise the use of recycled and reused materials, particularly driven by Victoria's big build, but in due course we'll see that roll out across all of the state's assets in road and rail infrastructure. It's a crucial time. You'd all be aware that China has restricted the import of our recyclables, and we can no longer sort of export our problem, if you like. And people would be well aware in Victoria of the problems that we've had with the landfill industry in general. So what that means is that potentially we are going to see large amounts of waste going, and more waste going to landfill, unless we can find an end use for that product. At the same time, we have this big build with $70+ billion of road and rail works that really has an appetite for materials as well, and that the conventional material suppliers will struggle to actually supply to, or if they do, costs will be potentially prohibitive. So we have this ability to turn a problem of recycled waste materials and turning those into recycled materials for road construction. So it's a great opportunity for us, and Ecologiq is really born out of that particular opportunity. And we will boost the use of recycled and reused materials across project life cycles. More importantly is that we're going to do this in an intentional and very deliberate way, and a uniform way, as opposed to the sort of ad hoc and opportunistic approach that's probably been around for the last 20 years or so. One of the ways we'll be really intentional about it is through the Recycled First policy. So this is government policy which was announced in March of 2020, and it applies to all major transport projects. And what it's saying is that bidders on future major transport projects are required to demonstrate how they'll optimise the use of recycled and reused Victorian materials. So it's an invaluable tool to actually drive an approach to using recycled materials and reused materials. It's also a way of building in future consistency in that application, and making the use of recycled materials a business as usual, uniform way of delivering transport projects now and into the future. And I think that sort of covers a bit of an oversight of or an overview of Ecologiq and what our aims and goals are, and probably provides good context for me to hand over to Joe from here to talk about Crumbed rubber. Really exciting topic.
Thank you. I was just waiting there for an unmute. Thank you, Tony, for that introduction. And in support of Victoria's Recycling First policy, there's a number of different recycled materials available for use, including recycled glass, reclaimed asphalt pavement, demolition waste, recycled plastic, and then also Crumb rubber, which we'll focus on today. So before we get into some details, let's have a look at where Crumb rubber comes from, what it is, and why do we bother why do we want to bother with using it at all. So essentially, Crumb rubber, the Crumb rubber that we're referring to, is an output from end-of-life tyres sourced from either truck tyres, car tyres, or a combination of both. And essentially, as you take those end-of-life tyres, when they're no longer in use, you sort it, you shred it, so you basically crumb it up into smaller particles, you remove the steel and synthetic substances, and you're left essentially with a crumb rubber-like powder, which varies in size, and what we typically use in the road industry in Australia is a particle size of less than 1 millimeter. Essentially, you take your rubbers, you shred it, you end up with a crumb rubber powder, and we can then use that in the road infrastructure, which we'll touch on later. So why go through that process, and why do we bother? So Tyre Stewardship Australia did a study did a recent study and found that an estimated of 58.6 million, almost 60 million equivalent passenger unit waste tyres were generated in Australia in 2018-19 alone. So what's an equivalent passenger unit? So it's essentially a unit where you, a standardized unit where you take truck tyres and car tyres and you convert it into an EPU, which allows you to basically compare apples with apples. And what that study found from TSA is that of that approximately 60 million EPU waste tyres that were generated, only 14% were recycled locally. So the remainder were either exported or, as we define it, as being lost. And what we mean by being lost is the recycled or the waste end-of-life tyres either ended up in landfill, it's stockpiled somewhere, or unknown, so nobody knows where it ended up. So as you can see, about 86% of our end-of-life tyres that we do generate in Australia is either being exported or not reused at all. And why is that important? First off, the ones that end up in landfill, they can create a significant environment and health and safety issues. Environmentally, if those stockpiles take fire, they can burn for days, months, and weeks, and even months on end. And we've seen some examples of that both locally and elsewhere in the world. It's a breeding ground for mosquitoes, vermin, diseases, and all sorts. So we want to avoid that if at all possible. And the same goes for exporting those tyres. It's not a very sustainable use of reusing our recycled materials. So rather than export, we want to look at opportunities to reuse it locally. Just a shout out at this stage to Tyre Stewardship Australia. They've been very proactive in supporting new developments for the use of Crumb rubber products, both in the road infrastructure industry as well as other industries, and they've been supporting a lot of this development work in the past. So how can we go and use this recycled tyres in our road infrastructure? And more specifically, we'll be focusing in this presentation on the use in sprayed seals and asphalt. At this point, I'd like to note that this technology is by no means new. It's been around and been used in the United States since the 1960s, and it's been used in Australia since the mid-1970s, albeit in Australia with a particular focus on sprayed seals, not so much on asphalt. But nonetheless, it's been used for many decades, so it's by no means new. There's essentially two ways we can introduce Crumb rubber into asphalt and more specifically into asphalt, and that's through either the wet process or the dry process. So the wet process is when you take that recycled Crumb rubber and you pre-blend it with your bitumen. And when you do that, there's some interactions that occur between your base bitumen and your rubber particles, which we call first the reaction stage and then an ongoing digestion stage. And as that digestion continues, the properties of your combined binder changes and it gets modified. And for the purposes of sprayed seals and asphalt mixes, it improves both your increases your viscosity, it improves your softening point, so it reduces your your temperature sensitivity. It also increases the resilience of the binder. And as you can see there on the bottom of the slide, that's a typical graph that shows the change in properties. As you can see, if you add your rubber to the bitumen initially, within that first hour, there's a significant increase in viscosity, and then that viscosity changes over time and drops down again. And it's important to note that change in properties over time, because that impacts on when you can use the binder and its binder handling characteristics. But also worth noting that graph there, the viscosity graph, is a surrogate for the other properties that I mentioned as well, including softening point and resilience. So as you can see, as you add that binder, both your viscosity, resilience, and softening point will increase, indicating an increased performance. During the wet process, we typically add between 10 and 20% by weight of the total binder of Crumb rubber particles. And for asphalt mixes, that total binder content in your asphalt mix can vary between 4.5 with a very upper limit of 10%, but usually more up at around 8%, depending on the mix type, which equates to about between 0.5% and 2% of the total asphalt mix can be made up of Crumb rubber. So that's the wet process. When we then look at the dry process, rather than pre-blending the rubber with the bitumen, we add it as an aggregate to the asphalt mixture. So essentially, there's only a limited amount of interaction that occurs between the rubber particles and the bitumen, and that interaction and digestion occurs only during the asphalt mixing phase, which is relatively short. So you have limited interaction. So essentially, your rubber particles acts more as a flexible aggregate. Because of that limited interaction between the rubber and the binder, you have less control over the ultimate performance of the mixture. But on the flip side, you have an opportunity to add more rubber into your asphalt. As you can see there, your typical contents as a percentage of the overall asphalt mixture is between 1 to 3% of rubber. So you can add almost double the amount of rubber using the dry process compared to the wet process. That said, both technologies have their advantages and disadvantages, and both are used both locally and internationally. So I suppose it's a matter of horses for courses. We have a look at the benefits of modifying both asphalt and sprayed seal binders with Crumb rubber. There is a number of benefits, and these benefits have been proven over the many decades since it's been first introduced. It's been proven both in service as well as through a number of research studies, both locally and internationally. So the main performance benefits of Crumb rubber modified binders are you end up with a modified binder compared to the conventional bitumen that's less sensitive to higher temperatures. It has improved rutting characteristics, so it's less sensitive to pavement deformation, as well as improved cracking and fatigue resistance properties. So you essentially end up with a modified binder that's tough, robust, and that can provide significant improvements in performance compared to conventional bitumens, which has been well established. Then, apart from just the performance benefits, there's a number of environmental and sustainability benefits as well. So the first and obvious one is you reduce the amount of recycled tyres or end-of-life tyres that goes to landfill or are being exported. there's an opportunity to reduce the demand on non-renewable resources if you use it as a bitumen replacement or an aggregate replacement. Benefits of using a otherwise waste product. And then again, because of that improved performance benefits, as well as being cost competitive with conventional bitumen and cheaper than more traditional polymer modified binders, in many applications or in many situations you can end up with reduced overall whole of life costs. Again, because of that longer service life coupled with a cost competitive cost for the binder. As you can see there, ultimately you end up with improved performance, better for the environment, and a more sustainable product, which in my mind is basically a triple bottom line benefit. So where do we use it? As mentioned previously, in sprayed seals and in asphalt. It's been widely used and in sprayed seals in Australia, as I said before, and we use it in these seals because it provides that improved flexibility and crack resistance. So it's a robust binder. It improves aggregate adhesion, so it reduces the risk of early life stripping of your sprayed seal. And then because of that higher viscosity, it also reduces the risk of bleeding and flushing. And what we see with using this binder in sprayed seals is because we have that reduced risk of bleeding and flushing. In some cases, you can add more binder to your sprayed seal, which in turn makes it more waterproof and crack resistant. It's most commonly used in more heavier duty applications, such as high-strength seals, strain-alleviating membranes, and strain-alleviating membrane interlayers. And Victoria, the Department of Transport, is widely considered as being the leader in using Crumb rubber modified binders for sprayed sealing. It's pretty much business as usual for them, widely used, more so on reseals, but there's certainly opportunities for new construction as well. But from an Australian perspective, the biggest growth opportunity for its use would be in asphalt. Like I said before, it's had limited application in asphalt mixes to date, but that's changing rapidly. So both the Department of Transport, Main Roads Western Australia, Queensland Department of Transport and Main Roads, as well as a number of different local governments around the country are actively exploring its increased use in asphalt applications. And why do we want to use it in asphalt? Again, because it does provide that increased resistance to cracking, both fatigue as well as underlying joints and reflective cracks, and also provides improved rut resistance, so reducing your risk of permanent deformation, specifically in your wearing courses. So again, there's significant benefits in using it in asphalt. Locally, there's a number of asphalt specifications available that would facilitate its use, specifically in Victoria. The first is a bitumen crumb rubber asphalt spec 421, which essentially uses the dry process to add rubber to the asphalt mix. The department also developed and published recently a specification for light traffic crumb rubber asphalt, so which uses both, again, the dry process as well as the wet process. And that's for your lighter traffic roads. And then there's also a APA, Australian Asphalt Pavement Association pilot specification that's been developed and published for the use of crumb rubber in both modified, in open graded and gap graded mixtures. So there are specifications available that will facilitate its use. When we look at some of those specifications, this is an extract from a reference guide for the recycled materials and road infrastructure that was previously developed by Ecologiq. So that guide provides a good overview as to the different recycled materials that's currently available for use, its application, allowable limits, and so forth. So I strongly recommend, if you don't have the guide yet, to get hold of it and have a look. This is an extract from that guide that basically gives you the limits of crumb rubber currently allowed for in Victoria. And if we look at asphalt applications, it varies between 0.5% to 3% of rubber by mass of the total asphalt mix, and up to about 15% by weight of the total binder using the wet process for dense graded asphalt mixes. And then for your sprayed seals, allowable percentages vary between 5 and 18%, with your lower percentages typically more used to promote aggregate adhesion, especially during the early life of the seal, and your higher percentages of rubber used for improved crack resistance, reduced risk of bleeding and flushing, so in your heavier demand applications. So now we've gone through what crumb rubber is, how we can use it, what's allowed, what specifications are available, and we'll move on to some of the barriers and opportunities regarding the use of crumb rubber in road infrastructure specifically. First, and very importantly, there have been over the years some perceived health and safety risks with the use of adding rubber to bitumen or in sprayed seals and in asphalt. The reason being that there's some concerns that at those elevated temperatures you burn the tyres, and it can potentially give off harmful emissions and strong odours. Now, in Australia, we've done a number of studies have been done locally, both in Queensland, in Western Australia, and more recently in Victoria, where those emissions studies have shown comparable emissions compared to our current practice asphalt mixes, so not necessarily an increased risk. More specifically, the studies have also shown the use of or the benefits of using warm mix asphalt. So to reduce those temperatures, a strong correlation was found between the amount of fuming and the temperature of the asphalt mix. So if you can keep the temperature down, you can significantly reduce the amount of fuming, which again will reduce odours as well as any compounds. Another barrier up to now, but again this is rapidly changing, is lack of available specifications and design guidelines specifically for the use of crumb rubber and asphalt. But like I said, there's a number of states and local governments that's actively developing new specifications and guidelines, so that won't be an issue for much longer. There is a need for some specialized equipment, more so when around the storage and handling of the binder, because like I said before, it's temperature dependent, its properties are temperature dependent, and it can be prone to segregation. So the binder essentially needs to be used within a specific time window or period, as well as be kept in agitation, or so constantly stirring to avoid any segregation. Again, those barriers can be overcome. One of the ways to reduce the risk of any storage stability issues is by blending close to the site, either the sealing site or close to the asphalt plant. So there's opportunities or options to do that. And then there's some local binder suppliers that have developed products that has overcome that storage stability issue as well by adding additives, and they've shown that you can haul these products in excess of 500 kilometers. So again, those barriers can be overcome. And then finally, specifically within the asphalt industry, limited experience because it hasn't been used widely in Australia to date. but because of the new specifications coming online and a number of road authorities desire to use this product, that's rapidly changing as well, with a number of contractors already having some project experience behind them, and we'll touch on some of those trials later on. Opportunities. There's a number of opportunities for the increased use and further use of Crumb rubber modified binders in both asphalt and sprayed seals. The first one is reducing the binder handling temperatures. So there's again work being done both locally and internationally to either add warm mix additives or pre-treat rubber that can bring that temperature down during the asphalt manufacturing and sprayed sealing operations. The benefits of that are twofold. First off, by reducing the temperatures, you have environmental benefits, so less heating required, and then also there's some health and safety benefits as well, whereby you reduce the amount of foaming and odors by reducing that temperature. Opportunity to create and to broaden that range of applications. So like I said before, typically in asphalt applications we use between 10 and 20%, but reducing that to as low as 5%, with the lower percentages more applicable to local government roads where you don't necessarily need a heavily modified binder, but you need a binder that's both sustainable and can provide some durability benefits. Again, also increasing the usage in more specifically open graded and gap graded applications. As we know and as we learn more about the binder, there's opportunities to optimize and improve its performance by considering whether we can use different gradings of Crumb rubber, whether we can use different base bitumens, different additives, and there's a variety of different opportunities to further optimize the performance of these binders. And then finally, a significant opportunity is the sustainability benefits of using a waste product in a very high value application such as road surfacing. So there's a number of different opportunities for us to explore and encourage the use of these materials. That brings it to the end of my portion of the presentation. I'll hand you over to Steve Patrick now, that will run through some case studies and trials that's been recently completed. Thanks, Steve.
Thank you, Joe, and hello to everybody watching the webinar today. Yes, as Joe described, I'm here to talk about a couple of case studies where Crumb rubber recycled product has been incorporated into road use. And again, as Joe mentioned, Crumb rubber has a long and extensive usage in sprayed sealing throughout Australia. And the first trial I'm going to be talking about is a recently conducted trial where Crumb rubber asphalt were being trialled in the metropolitan part of Melbourne. Next slide, please. Yes, this trial was conducted in a section of East Boundary Road in East Bentleigh, southeast of Melbourne, and was paved using the equivalent of 1,600 used vehicle tyres. This section was laid over a 1.5 kilometre stretch, and laboratory and field tests were conducted and will be monitored over the next 2 years for ongoing field performance. The trial has included 4 different asphalt mixes incorporating Crumb rubber and 2 asphalt control sections for comparison. These are all laid in the southbound carriageway between Centre and South Roads if you'd like to visit, now that most of us we're nearly all out of lockdown. This was a big collaborative effort, this trial, between the Victorian Government, Tyre Stewardship Australia and the Australian Road Research Board. We're conducting this $1 million study, which the overall aim is to incorporate more discarded tyres into the circular economy. I guess also this trial has more relevance or broader relevance in terms of recycled products altogether as trials such as this, introducing new products. The framework of this trial can be used for the introduction of other recycled products such as plastic in the future. Next slide, please. Now, the purpose of the trial is to introduce crumb rubber asphalt into a metropolitan setting. Many asphalt manufacturers had developed crumb rubber asphalt products, but they were not able to use them extensively because they do not comply with current specifications. The trial is an opportunity to test the crumb rubber asphalt products, both in the laboratory and also in the field under real traffic and climatic conditions, to assure performance standards that can be included in future specifications. The trial was a substantial and collaborative effort between many parties. The Department of Transport took a large role in site management, product procurement, technical direction, and the industry liaison. The Australian Road Research Board is responsible for the laboratory testing, condition monitoring, the technical advice, and a lot of the project management. And Tyre Stewardship Australia largely setting the strategic direction and project management. There was also a large collaboration with industry. There's obviously introducing new products the industry is relied on for their technical expertise, and they played a big role in development of this trial too. Next slide, please. Now, the crumb rubber asphalts used in the trial, an invitation was set up, or an invitation was sent out, I should say, to industry to submit proposals for crumb rubber asphalts that may be included in the trial. And there was some variety between the crumb rubber products that were selected to be paved. This process was largely left up. After the invite, there was not a lot of direction given to the types of crumb rubber asphalt. So this was an opportunity for industry to develop innovative products and give them a shot on a road in a real life situation. The trial ended up including crumb rubber products from 3 different manufacturers, and we ended up with 3 different types of crumb rubber asphalt. There are 2 SMA type N crumb rubber asphalts, a gap graded asphalt, and a dense graded asphalt, all made with crumb rubber. These crumb rubber asphalt products also included a range of crumb rubber dosages that went up to 20% of the binder mass included. And Joe was describing the wet and the dry mix types earlier in the presentation, and we had examples of both of them included in this trial. Next slide, please. And yeah, the trial relied heavily on the collaboration, shared effort, and risk between all the involved parties so that these products can be successfully introduced in the future, hopefully. I guess one of the purposes of doing a trial is you really force the issue, and it's a chance for everyone to get practice and force the problems to the forefront that can be dealt with the introduction of these new innovative products. Some of the issues faced by the trial included a late withdrawal of a product by a manufacturer due to compliance concerns. So a product had been nominated, but further into the testing regime being undertaken by the manufacturer, they found they weren't able to achieve the performance standards they were hoping for, and so there was a late withdrawal of the product from the trial, which had to be replaced. There was some trepidation regarding the emissions and fuming due to the lack of experiences with products from the paving contractor. I guess traditionally, anyone that has worked with a crumb rubber product will be familiar with the smell of these products, which smells just like a car tyre that is either being screeched along the road from a heavy braking incident or a loss of traction incident. Hopefully with modern cars that shouldn't be happening so much. But if anyone is familiar with that smell, it's not uncommon for that smell to come out when they're being incorporated into road making procedures. And there was some concern about what the impact of the fuming and exposure to these type of fumes would be. And so that was something we had to face and deal with as part of the trial. And midway through construction of the trial, when we were facing some poor weather conditions, there was hesitation from the manufacturer to provide a product in those marginal weather conditions. I guess the again, part of the reason why you do a trial with long-established products with lots of experience. It's a lot easier to deal with, and people know what the expectations around performance will be. But marginal conditions with a new product, there was some trepidation from the manufacturers to provide those products in those conditions. It just took some site management. But again, these are the type of problems that can come up when introducing products in a trial such as this. Next slide, please. Once the trial was constructed, the construction happened back in March, that immediately set off the monitoring program. During construction, the fume exposure from the crumb rubber mixtures was measured, and emissions were monitored for several airborne contaminants and undertaken in the breathing zone of several of the paving operators. Significant amounts of asphalt and raw materials were sampled and collected, so that extensive laboratory testing could be conducted on them to assure the performance requirements. A detailed condition assessment of the trial site was completed before construction to identify factors that may influence the ongoing performance of the trial CRA mixes and give a benchmark to judge any later performance on. The monitoring of the site condition commenced immediately after paving and will continue for the next 2 years. And that monitoring includes rutting, roughness, cracking, and texture, as well as video records of the trial site. Next slide, please. So far from the trial, 7 months ago, the trial was established, and all of the crumb rubber mixes were successfully paved. The emissions monitoring has shown comparable emissions compared to the control mixes, which were SMA mixes. The laboratory testing program has established performance levels that did conform to the expectations provided by the manufacturers. And the condition monitoring is tracking the performance of the crumb rubber asphalt in situ and allowing comparison between the different mix types for various performance measures. As I mentioned earlier, there are a range of different products on the road, and they are showing some differences in performance, but pretty much as expected as this stage of the trial. Next slide, please. There are just a brief run over some other case studies throughout Australia where crumb rubber asphalts are being used, specifically in Queensland and Western Australia. Next slide, please. The trials have been embarked on in Queensland and Western Australia, particularly focusing on graded asphalt and open graded asphalt. These trials were examining the use of an 18% crumb rubber modified binder. The open graded asphalts have been successfully trialled in both Queensland and Western Australia to this point. In Western Australia, over the last financial year, they're successfully implemented within a design and construct contract, and looking to increase the use of these crumb rubber products over the next financial year. Again, the gap graded asphalt had been used successfully in Queensland and Western Australia, and successful trials using both 7.8 and 8% binder contents in the asphalts. These asphalts have so far shown improved fatigue life compared to conventional and unmodified dense graded asphalts. Again, emissions monitoring was carried out for these trials. So next slide, please. We're up to the questions.
Thanks, everyone. Perfect. We've got quite a few questions come through, so we'll get started. The first one is from Andrew, and they have asked, what is the increased modulus of crumb rubber in AC mixes typically, and is it used in design and accepted by DOT when designing asphalt thickness?
Thanks for that question. I'll take that one to start off with. So because crumb rubber binders are mainly, or at the moment exclusively, being used in wearing courses, So its structural contribution to the overall pavement structure is not considered to be significant. So it's not used as a structural layer at the moment. It will have a lower modulus compared to your conventional bitumens because of that elasticity in the binder as a result of the rubber, and also the higher binder content. So it has a lower modulus compared to conventional asphalts. But having said that, it's not expected to provide a significant structural contribution to the overall pavement structure. So it's not necessarily a concern. As for the Victor requirements, they have a specification for its use. Within the pavement structure, there will be some presumptive modulus values that you'll have to adopt. But again, it won't make a significant difference on the overall pavement thickness.
Perfect, thanks, Joe. We've got another question from Roshanak, and they have asked, does crumb rubber used for wearing surface, or is it just used for base and sub-base?
Yeah, I should have clarified that at the beginning. It is a wearing course mix, so it's used within the upper pavement structure. So because again of that lower modulus, it won't necessarily be cost effective to use it as a structural base layer. We use it in the wearing course for improved fatigue resistance and improved rut resistance.
Thanks, Joe. We've got a question from Kathy, and they have asked, is the asphalt still recyclable through RAP with the crumbed rubber content?
That's a very good question, and it's something that's currently being investigated. So there have been some limited laboratory studies done in the States where they investigated the use of recycled asphalt or reclaimed asphalt pavement wrap that contains crumb rubber into new asphalt mixes, and that laboratory study didn't find any concerns. It did recommend that some further field validation be required, but anecdotally, like I said before, crumb rubber asphalt has been used in the States, more specifically in California and Arizona, since the 1960s, and they routinely recycle those wearing courses back into new mixes, and they haven't experienced any in-service performance issues to date. I know Main Roads Western Australia, through their Warwick research program, is also investigating recycling crumb rubber wrap back into new mixes. And one of the things just to consider there is how you deal with the binder viscosity of the crumb rubber, because if you extract your binder, you leave your rubber particles behind, so you don't necessarily have a representative binder. So in short, there's some design considerations that needs to be taken into account, but at the moment there's no evidence suggesting that it would be an issue.
Thanks, Joe. We've got a question from Jenny, and they've asked, can crumb rubber be used in a pave liner as the aggregate replacement?
Pave liner, Tanya, I'm not too familiar with the term pave liner. Tony, are you familiar, or Steve? Are any of you familiar with the term?
No.
So
crumb rubber is obviously asphalt just laid conventionally through an asphalt paver. That could also, be a material transfer vehicle. So it's used in the same conventional way that asphalt is used, I guess, in terms of placement. Steve, I don't know, you were about to say something. I probably put it in there. But...
No, I think I was about to basically say a very similar thing at this. Yeah, there's maybe referring to a wet and dry addition of crumb rubber into the mixes, both of which are possible. But yeah, unless we have any further clarification, I don't have anything further to add.
Yeah, so as in the dry process, it's used as an aggregate replacement. So yes, and like Tony said, you use conventional paving equipment what you would use for your conventional asphalts as well. I hope that answers it. If not, feel free to get back to us, and we can provide you with a separate answer offline as well.
Thanks, Joe. We've got a question from Martin, and they have asked, in the application of primer seals, is penetration into granular pavement and possible cement modified pavement reduced when using crumb rubber as a primer binder?
Yeah, look, I mean, the penetration wouldn't be the same as for cutback bitumens. So because of that higher viscosity, I'm not aware of it being used as a primer binder in the past. So, but I would expect that penetration to most certainly be less than your cutback type binders.
Yeah, I think just to add a little further to that, I think in the most recent update to the Austroads sealing guide has included the use of crumb rubber. Crumb rubber is allowed to be used as a primer binder or initial seal binder, as the terminology now calls them, and that was actually extensively trialled across Victoria with collaboration of spray lines. So yes, you could imagine the penetration would be less, but I think yeah, especially with the latest advice around there, the advice more focuses on making sure that the steel sticks to the pavement rather than straight up penetration of the binder into the pavement. So I hope that answers the question in a succinct enough way that you can use crumb rubber binders as a primer seal / initial seal, and yeah, that is encouraged by the national documentation.
Thanks, Steve. We've got a question from Georgina, and they have asked, thinking back to previous week's topics of using crushed glass in asphalt mix, can crumb rubber be used with glass fines in the same mix?
Yeah, look, in theory, I can't see why not. There's nothing that precludes its use. I suppose you raised an interesting question there in terms of starting to combine different recycled materials within an asphalt mix, whether it be crumb rubber, crushed glass, reclaimed asphalt. That's why I'm a strong supporter of moving towards more performance-based specifications, so that we can measure the outcome and or expected performance of the asphalt mix, irrespective of the individual components. But in theory, yes, I can't necessarily see any issues with it being used in combination with glass.
Thanks, Joe.
Thanks.
We've got a question from Mitchell, and they have asked, how does crumb rubber increase adhesion of aggregate in the early life of a spray seal?
I wonder I'm not sure what the technical term for it is, but it is more sticky. It's a more sticky binder. So yeah, so it has improved adhesion characteristics through that change that happens in the binder as the rubber and the bitumen blends. Steve, do you have a more technical term for sticky?
It's just like enhanced adhesion capabilities. If you can, yeah, if you can get your aggregate onto a crumb rubber binder in an appropriate amount of time, there is to get back to the simpler term, it's very sticky, and if you can get it on there, it has good potential to hold better.
Yeah,
I sort of like the term tenacious. The tenacity of it is incredible, and you know, if you can sort of picture a piece of aggregate stuck onto a rubberized bitumen seal, and you try to pull it apart, it will stretch and hold and grab, and as you try to stretch and pull it, it will want to hold on and pull it back. So if you think about the rod tyre, particularly a heavy truck tyre on that aggregate, it's trying to, in some ways, it's rolling onto the aggregate and pushing the aggregate out of the spray seal, and trying to unleash it and putting that pressure on it, and the rubber just has that tenacity to hang on to it so much more than a conventional seal, so you'll get less aggregate loss, particularly early on. I think hopefully that explains it.
Thanks, Danny. I'm gonna hold on to that term tenacity. Yeah, much more technical than sticky.
No, sticky works for me too.
Thanks, guys. We've got another question come through from Prunette, and they've said, thanks, Steve, for insights about Crumb rubber binder. Could you please give some more information about emissions monitoring? Any studies on non-exhaust emissions?
Okay, I guess what the emissions monitoring that I was talking about during this presentation were several of the paving crew members were wearing emissions monitoring gear throughout the shift. We were monitoring for several airborne contaminants, some particular that in international studies have been raised as concerns as being particular to crumb rubber binders, and being not a brand new technology, but a developing technology. There were, the links have been drawn, but not completely proven. And so we monitored for a large amount of airborne contaminants. I guess the results aren't, can't go into too much detail about the results, but generally the results were very encouraging. And I guess even just observing on during the paving of the trial, many of the crumb rubber mixes incorporated warm mix additives to keep the mix and paving temperatures low. And first observations would be that the fuming and the emissions seem to be much higher with the higher product temperatures. So yeah, in many cases the crumb rubber products were being paved at lower temperatures and thus had less emissions and less fuming. So I hope that answers the question, but yeah. I don't know, Joe, do you want to add any more about the NACO and Warwick?
Thanks, Steve. Just to add to that, as mentioned in Steve's part of the presentation early on, similar studies were done in Queensland and Western Australia on demonstration trials there as well, whereby the emissions were monitored on workers, so worker exposure emissions on site, paving crew, roller operators and the like. And again, for those studies, those emissions were found to be below the exposure limits and like we said, comparable to the control sections. But temperature is key. So if you can reduce the temperature, you reduce the risk of emissions. But I should add that goes for any bituminous type product, including polymer modified binders as well. So anywhere we can reduce temperatures is better in general.
Yeah, and look, I might just add, emissions testing is one thing, and I think emissions don't necessarily mean, odour is a different thing to emissions, and the sort of odour you will get with the same emissions from a conventional bitumen versus a rubberized bitumen are different and definitely more unpleasant. And in some cases that can be, quite in the short term, quite uncomfortable and discomforting to people who are in proximity and working there. So it's a really important consideration from a health and safety perspective and from a usability perspective. And so the solution of using warm asphalt is, I think critical to the future in asphalt applications of crumb rubber.
Absolutely.
Thank you. We've got a question from Saeed, and they have asked, if crumb rubber reportedly softens the mix, i.e. lowers the resilient modulus, what contributes to its rut resistance characteristics?
It's the higher stiffness. So it's the higher viscosity of the binder at higher temperature. So if you have a look at the softening point increases significantly. When you add rubber, I've seen a recent study, I just came across something recently by chance where where in France they investigated it, and essentially what it came down to is by adding 10% rubber, they found that you increase the performance grade of the binder, which is a US specification type approach, by 1 grade, so increasing that higher temperature susceptibility by 1 grade. So it's as a result of that that increased viscosity that you get from that binder rubber interaction.
Thanks, Joe. We've got a question from John, and they have asked, is there any perception of a decrease in friction factor with CRA, especially in wet conditions?
Yeah, look, that's a very, very good question, that as well. It depends on the mix type. So very similar to, so let's start off with gap graded mixes. You typically, because you have a higher binder content in your gap graded type mixes, you have a thicker film thickness, and which can impact on the early life skid resistance of the mix, similar to what you would have with a SMA. But as that binder film wears off through traffic, your skid resistance return to normal conditions again. So as an example, for gap graded mixes, we encourage the use of gritting to provide that early life skid resistance, similar to what we typically do for SMA mixes. Less critical for your dense graded applications because you do have similar binder contents compared to the conventional mixes. But yes, early life on your gap graded type mixes is something to consider, but can be managed through gritting. Thanks.
Thanks, Joe. We've probably got time for one more question, and that's from Peter. And they've asked, for sprayed sealing, what is the optimum part of the viscosity temp curve at which to spray?
Steve, you wanna take this one?
It will depend on your product and the dosage. If we're talking in particular Crumb rubber products, whether you're dosing it at 5% or 18% can tend to influence it. But yeah, there are a number of factors that are going to come into the best spraying temperature for sprayed seals. But yeah, typically between 180 and 200. But I don't have any specific advice to offer for that, I'm sorry.
But it's like you said, Steve, it's between 180 and 200 with your higher temperatures, typically for your more heavily modified binders. Again, I'd like to point out here that something to keep an eye out on, there is some international development work being done on these binders where you can reduce your sprayed sealing temperatures as well by pre-treating the rubber or adding warm mix additives. So there's opportunities to reduce that temperature down in the sprayed sealing application as well.
Perfect. Thank you, guys. I think that's all we've got time for questions. So I just wanted to say thank you to our presenters today, and thank you to our audience for tuning in. We hope to see you all at our next webinar, Demolition Waste Masterclass, on the 11th of November at 12 p.m. Thanks, everyone.
Thank you. Enjoy your day.
Thank you.
Bye.